Thank you. So here's no mistake, I am from Accenture. And do we have a clicker? Peter? This one? Okay. Yeah. So thank you. We are very excited to be here today. And I would like to continue on the point from Benno and Laura earlier this morning. We would like to share with you our experience in using generative AI, agentic architecture, and multi-agent system in real processes in engineering today, and share what works well for us, what doesn't, and where we see a lot of potential. And I would like to start with this thought that one of the perspectives on thinking about why co-pilots in software development are so efficient is because code compiles. So the systems in software development get immediate feedback after structural changes in the code and get a feedback on how to improve it. Which other areas compile? Just last week, we've seen the new model by Google, AlphaEvolve, which also can compile math. It was able to improve its own algorithm, actually improving efficiency and reducing the energy consumption by 1%. Everything by itself, just compiling math. I would like to put the question in the room, what will happen soon when we will be able to compile engineering 2, creating a digital reasoning thread from requirements to engineering and simulation verification. I will explain this more on the end of my presentation. Maybe just to summarize our road and our journey in this direction. So we started in this area around about 2015, helping clients in aerospace and their engineering tasks, automating it. Now, straightforward to 2025, we have now more than 4,500 engineers globally and 2,000 engineers located in Germany alone. So if you imagine a room full of 2,000 people sitting side by side, you can get kind of a feeling of our excitement about this topic, but also of urgency in integrating the AI in real processes, skipping from POCs real to real processes acceleration. I think, as many of you, we also discovered a lot of application of large language models in engineering. And it was an exciting journey. We also learned that we can use it for acceleration of our work with requirements. We can analyze technical drawings. But for us, it was rather a challenge, since now we have to handle also this complexity. We have an ocean of use cases, and the question is how we can improve real processes and not build a ton of POCs. And for this, we had probably the same journey as many of you here. So 2 years ago, 1.5 years ago, we learned how to efficiently use RAG in our systems. Later, unfortunately, we figured out that RAG does not perform so well in industrial contexts. Similarity search is not super helpful in many areas where we have a lot of data which looks similar, but there's a lot of different domains within it. So we learned how to leverage knowledge graphs to add ontology and semantic to this data. Later, we learned how to encapsulate this business logic in agents, giving this agent tools and access to third-party tools, knowledge, system prompts. And it was great, but also here, for industrial, it was not scalable for us. And the reason is, as Laura mentioned in the morning, we would like not only to process data as text, we have a huge variety of use cases. We would like to work with technical drawings, with video, with audio, and on the same side, we have a variety of outputs, which we also would like to leverage. And the question is, what is the future? Having 200 co-pilots for each task, having a store for your co-pilots, or one almighty co-pilot which can manage everything? And this was even the first question. The second question is that we would like to leverage not only the generative capabilities, generating text or code, we would also like to leverage reasoning capabilities and the ability to orchestrate tasks. So we thought about, does it make sense for us to invest in this area, or should we sit and wait? And to be honest, we believe that there's 3 bottlenecks at the moment in the industrial space which kind of limits the integration of agentic in engineering. The first one is the variety of different disciplines and domains we have to cover. If we compare it to other industries where we have basically one domain and you being efficient using, I don't know, Word, Excel, and your Jira, we have absolutely another story here. We cannot put in one context so different domains. Maybe you had similar experience that mixing many domains in one context is leading to poor results. So we have to separate it. The second point is that we have to use real tools to be efficient. So it's not good enough for us to having a nice Copilot where our engineers will have to copy-paste all results from Copilots to their tools and vice versa. We don't believe that this approach will really help to get more efficient. And the third problem is that we have many different types of syntax in engineering and R&D, and all of them evolving. So just 1.5, 2 years ago, we have, for example, now SysML2, which introducing new way of syntax in one of the domains, and we would not like to rebuild our system and retrain our models just because of this update. And there is 1,000 models on the market introducing each month. So a question, how we can approach that? We would like to share one of the possible solutions which we use for our own projects, and I think it's very creative, and talking to many of you today, I think it's pretty unique, so maybe it will inspire you to try it out as well. What you will see in a second is an orchestrator layer, and you can imagine this orchestrator of being a project manager. So it has not really expertise in any of the fields deeply. It can't even operate any of the tools, but it's very good at delegation and splitting the complex task in smaller chunks. On the bottom, you will see different tools we have to operate in order to be efficient. And what you will see in the middle, you can imagine them as being an executor. Yeah, so this executor is the kind of AI APIs, bringing this together, and their only goal is to serve as an interface between the orchestrator and our tools. In a second, you will see a short demo of an engineer using only one prompting window to change his product. It will be a battery cell, and the engineer will ask this orchestrator to increase the capacity of engineering cell by 30%. So let's start the demo. And you see in the middle this orchestrator. The orchestrator is connected to 4 tools, of course, from Siemens portfolio. And you see the Polarion, you see the NX, and HyperMesh and HyperView on the bottom. The first step of this orchestrator will be loading the restrictions and constraints from the Polarion. And now the user asks, for example, to increase the cell capacity by 28 or 30%. One of the solutions which this model suggests is to increase the number of cells from 3 to 4 layout to 4 to 4 layout. And if your user accepts this change, this model will proceed. It will import this new model to HyperMesh and will solve this new model. After it, the user can again continue and say, check the design safety. It will import it to HyperView, and we will see the stress distribution for this model. And the model sees as well that we have some too high pressure around the WOM design of the cells, and it even suggests the improvement. It suggests to increase the thickness of the walls, and we will have a new iteration basically from the beginning, from requirements to simulation in a loop. And we can let, as Laura mentioned this, a digital colleague work in this tandem for a few iterations and see what will be the outcome. On the other side, you see what's happening behind. We have this one window acting as a one interface to this whole chain, and is up to user. So anytime you can just go as normally to your tool and make any modification. If you work with any code editor like Windsurf or CursorEye, it's a similar strategy. So up to user to confirm the changes or make them own. This model just suggests one of the ways. And after a few iterations, we see that the model will find now one optimal solution to this approach, suggesting one optimal design which fits the requirements and the changes. And from this point, and this is the most important part, a senior engineer can take this design and think it further. Yeah? So it's just a suggestion, saving a lot of time in iteration. So there's some statistic that around about 40% of all work in engineering design is in the area of work which consists in iterations. Yeah? You can't just imagine the amount of work people have to invest to search for designs will be thrown away later. So the idea is to improve or skip or reduce the step, providing a better solution from the beginning. I know it was compressed, but you can just join us on our stand number 14 and try it by yourself, designing your own parts in battery design or airplane parts. Why we are excited about this approach and we would like to discuss it with you is because if we come back to the challenges I just mentioned at the beginning, we think this approach solves some of them and gives an interesting outlook on the future of engineering. Like, for example, now we can really separate different domains, having these agents We don't have to retrain the whole system. They're interchangeable. We can also access the tools directly from this orchestrator, but this is also just a start for us, because later, as we had the system, we figured out further steps how we can use it. Like, for example, we can save tokens by splitting the logic and having expensive reasoning models on the top. As the project manager, it has to reason, and having cost-efficient models as the executors on a level deeper. And these models can come from any supplier, basically. We also learned that we can use macros to optimize or use tools which don't provide the API yet. So we can just script them and have kind of a digital duct tape for the processes where we don't have a proper API yet. And it works for us to not have a break in our process and automate and skip the steps, which we cannot optimize normally without this step. The third one is the integration of these practices. It was also something we learned that we can integrate in the same approach to Orchestrator and store there our best practices, especially helping junior engineers to leverage best practices in the company. And the last one is one which I'm particularly most excited about. You can run a lot of them in a parallel, in the background. So the idea is really that once this loop is connected and you have this digital thread from requirements to the simulation, you can let run them, and in the end, you will get a summary of the designs and pick one which fits your requirement. So I know it was a kind of a compressed, so just please visit us on our stand. You can design your own parts and take them home, and you can say at home that you designed your first AI part with an agentic system in engineering. And we would like to continue discussion, since we believe that we together as an ecosystem can really define the future of AI-driven processes in the industry. Thank you very much.
Wow, you're getting faster all the time. We would even still have, as you did finish
sharing
too early.
Is caring, so sharing
I'm
for
perfectly okay. There are still 2 minutes, 3 minutes left. If somebody wants to ask a question, feel free. You don't have to. Sorry, Vlad. Oh, there is somebody.
With which kind of software CAD/CAM does it work? Only with Siemens, or are you open to any kind of platform, or how do you overcome this?
Yeah, so we have this example built on a Siemens portfolio, but we have other tools as well. You can visit our stand and just try different versions. Basically, it's about building up this chain in the process, and the tools itself are, I would say, exchangeable. Yeah, you're welcome.
So thank you very much for the presentation. Very interesting. And I fully can understand this works on the level of a part. But if I go to a more complex system, like an installation, we make a simple example, conveyor installation on a shop floor with multiple input outputs, right? Throughput requirements. Have you experienced this approach can work as well?
It's a great question. And that's why in the beginning I mentioned that this is a foundation in our perspective. So what we like about this use case is this way of thinking, of splitting the business logic between the orchestrator and these executors. Talking about the most challenging question, of course, if we go into system engineering, we have a tons of complexity of requirements, and there's a lot of work to be done, really, for this system to be able to proceed it. But we already see, especially with very routine tasks, where people repeat the same processes over and over again, where we can handle this complexity, but there's still, of course, a potential to go upstairs, handling the complexity of real complex requirements. You can also try it on our stand, so we have different products, the simple one and the complex one, and you will feel like the range.
One final question. Everybody happy? Thank you very much, Vlad.
Thank you.